Okay, now we're going to track down a low power situation if we have a jumper loose. We already did a scenario where the connection between two optimizers in a string was open and that cut out one of those strings. Now we're going to investigate what it looks like if the jumper to the entire string is loose. Let's check out how we would diagnose that. Let's go up here to our beginning choices. What's the condition on our inverter? We notice that it's that condition where we have green light steady, power is greater than 0, so the system's operating. I choose that. But is the power below what's expected? And remember, whenever you have a question mark, which is more info, bring that up, and that clues you in and gives you all the explanation of the fact that we expect 3,000 watts at this time of day from this system. We expect 3,000. It's below 3,000 indeed. So is the power below? Yes. Now, is the power 1/2? And that's our critical question to see whether we have a problem with an entire string or maybe just a module or two. In this case, yes, we have 1,500 instead of 3,000. So the power is 1/2 of what's expected. So I'm very suspicious now that I have a string problem. So I'm going to say yes. So now I start investigating. First thing I do is I go to my switch, turn off the power to make it safe inside the disconnect switch from the DC power from the array. And I take off my cover. Remember, the first thing that we always do is look to see if any wires are disconnected, but we can see in this case all the DC wires over here are connected into their terminals, so there's no problem there. So any DC wires disconnected? No. So now I bring up my multimeter. I'm going to touch on it and just move it over to the side here. I'm going to be able to use the multimeter to make current measurements. Turn the DC switch back on and measure DC current in string 1 to see if we have 0 current. So what we're trying to do is identify which of our strings, string 1 or string 2, might have a problem with current. Right now we have the current turned off, so remember to turn this back on, and our power comes back up and shows us our 1,500. And then on our meter, notice that it's already set to DC amps. If it wasn't, you would turn the knob to DC amps, and then we're going to use the current probe capability here, the clamp-on current probe. We're not going to use the two individual probes we use for voltage. We're going to use the tip. So what I'm going to do is touch on that tip, drag it, bring out a sort of phantom device, and have some targets here on my wires that I'm going to measure. I'm going to put my tip on circuit 1. Oh, and I get 0. Haha, okay. Now I'm going to move it over here, place it on 2, and I get 4.3. And if we go back here to our more info, it brings up an explanation that shows that if we have 1,500 watts and the system is operating at 350 volts DC, which is the nominal voltage given by the manufacturer, if you divide, you get 4.3 amps. So 4.3 amps is flowing through string 2, but if I take my tip and I move it back here to string 1 and let go, I get 0. So apparently all the current that I need to get my 1,500 is flowing through string 2, and none is through string 1. So I'm going to take my tip and bring it back up here. So that helps me identify that I've got a problem with string 1. And so now I'm going to try and track that down and see where my problem is with string 1. So I say string 1, 0 is at 0 current. So first thing I do is teleport up to the array junction box, and I'll zoom in a bit here to take a look to see, are any of the MC4 connectors loose? Well, we've run into this before, but no, in this case, all my connectors are connected together, so I haven't lost my string 1 in this case. So I'm going to say, any loose wires? No. So now I start looking underneath. The first thing I'm teleported to is this connection. I'm going to move out a little bit here. This is my connection between optimizers. So I'm looking to see if, here's my wire from my optimizer, and if I zoom over here, slide myself over a bit here for you, you can see that the other wire is going to another optimizer. So this is in between two optimizers. I'm going to slide myself back. So I've got my situation here where if we look at my electrical circuit diagram, this would be a location somewhere between optimizers. Each one would have to be inspected. And we're seeing that, no, in this case, we don't have a break in the wire between optimizers. So I come back here and I'm going to say, is there a break between optimizers? No. But now I want to look at the jumper. And indeed, okay, here's my problem. You can see that here we're at the end of the string. And if I bring up my circuit diagram, we can see that we're looking at this location at the end of the string, not between optimizers, but between the last optimizer and its jumper that brings the entire string back. Coming back to our situation, we can see that indeed that was left open. Either it came loose or it was not connected during the haste of finishing up the job. For some reason that's wrong. So that's the problem. Is string 1 jumper disconnected? The answer is yes. So the fault is found. And obviously what you do is you touch on the connector and make that connection. And congratulations, you successfully fixed the problem. If you want, you can have a little fun at the end of the simulation. Down in the lower right, we have these teleport locations. I'm going to click on it, and it brings up a whole range of locations that we can jump to teleport to examine the situation. I'm going to jump from here down to that inverter location. And indeed, we can see that now that we've connected our circuit back, instead of 1500, we have our 3000 watts, indicating that we've, put both strings back in operation.
Hey, thanks for watching the training video using Interplay's simulation-based training program. You can keep watching our solar videos by clicking on the link to your left, or stay up to date on our latest solar snacks by subscribing on your right. To learn more about how the STP provides critical team training and helps you build an onboarding program at your company, please go to interplaylearning.com.